All right, we're going to build on proving triangles congruent today by going a step further. So first let's talk about the definition of congruent triangles. We've talked about this before. If two triangles are congruent, then the corresponding angles and sides are congruent. That's the definition. Now we have a fancy way of using this definition in our proofs by using the letters CPCTC, which is kind of an abbreviation for the definition of congruent triangles. The corresponding parts of congruent triangles are congruent. So I would accept either one. If you want to say the definition of congruent triangles, you can. CPCTC is kind of a shortcut to it. We'll use this abbreviation to prove that the parts of a triangle are congruent after we've used SSS, SAS, ASA, and AAS to prove that the triangles are congruent. So this CPCTC only follows congruent triangles. They have to be congruent first for us to use them. So let's see how this works. So we'll take a proof similar to the ones we did last. SU is congruent to UV. We're going to prove that ST is congruent to VT. And the way we're going to do that is by first proving the triangles are congruent, and then these will be the corresponding parts. So we start with number one. SU is congruent to UV. That's the U. Now, what else do I notice in this picture? I've got my reflexive property, my shared side. TU is congruent to TU. That's the reflexive property. Reflex prop. Now, I need three things to prove that triangles are congruent, so I'm looking at my picture for something else that they might have told me. And what do you see right there? Perpendicular. The lines are perpendicular. So here's where we're going to go with that. Because of that right angle that they gave us, segment TU is perpendicular to segment SV. I'm going to say that was given because they just drew it in the picture for us. Now, to go from perpendicular, there's a couple of steps we have to use. The definition of perpendicular says that two lines intersect to form a right angle. So if I have perpendicular lines, I have right angles. So I'm going to say that angle TUV, angle TUS are right angles. That's going to be my definition of perpendicular. Now, when I have right angles, do you remember from the last lesson that all right angles are congruent? Once I have right angles, I'm allowed to use this theorem. So I can say that angle TUV is congruent to angle TUS because right angles are congruent. So I've got those two. Now I can prove that my triangles are congruent. I'm running out of room. Triangle STU is congruent to triangle, remember the letters have to match, STU and VTU are congruent by SAS. Finally, now that the triangles are congruent, all of the corresponding parts of these triangles are congruent. So I could say that angle S is congruent to angle V, angle STU is congruent to angle VTU. I could say any piece of this is congruent now. But what's the piece they wanted me to say? Segment ST and segment VT. So number 7, segment ST is congruent to segment VT because of CPCTC. Because the corresponding parts of congruent triangles are congruent. So we proved that our triangles are congruent, and after the triangles are congruent, we can pick any corresponding parts and make them congruent too. And we just pick whatever parts they told us to pick in the question. All right, let's do number 3 together, because whatever I don't do with you is going to be assigned for your homework. Number 3, GH is parallel to IJ. We haven't talked about parallel lines in a long time. So here's parallel. I do know several things are true about parallel lines, so we'll get to those. And then it says angle IGJ is congruent to angle HGJ. So I'm going to write those as my given. Angle IGJ, HJG. So confusing when they put the letters G and J together. So there's my given. Now if I look at the picture, because there's no definitions or anything to use in the given, so look at my picture. Well, what can I glean from the picture? Well, there's the reflexive property. So I'm going to say that segment GJ is congruent to segment JG by the reflexive property. Now someone's wondering, why did I put GJ instead of JG, and could I just put GJ and GJ on both of them? Because they're line segments, the order of the letters does not matter. So if you write segment GJ is congruent to segment GJ, that's perfectly fine. Now when you name the triangles, you have to switch the order of the letters to make them match. But when you're saying the reflexive property, that's the same segment no matter which order you put the letters in. Now that's going to bring us to our parallel lines. If my lines are parallel, let me think. We had alternate interior, corresponding, same. We had a lot of different types of angles that were congruent. So I'm going to highlight my transversal right here. And hopefully you'll see the Z shape. Remember, the Z shape indicated alternate interior angles. So that's going to be my number 3. Angle HGJ is congruent to angle IJG. And that's going to be the alternate interior angle theorem. Now if you forgot the name of that, then you just tell me if the lines are parallel, the alternate interior angles are congruent, because that's what the theorem says. Again, if you forget the name of the rule, just write down what you know, because we're looking for, do you know the information, not did you memorize the name of the theorem. So if you understand it, then you get credit there. So now if I look at my picture, I see angles and a side that's in between the two angles. So I'm going to say that the triangles are congruent by ASA. 2 angles and a side in between. Now when you name your triangles, remember the order of the letters does matter. So I'm going to name my first one IJG, just because I did. No particular reason. Then I'm going to go to my second one and make sure the letters match up. So if I went IJG, I'm going to have to go HGJ. So whatever you choose for your first triangle, just make the second one match, and you'll be all set. Now, my triangles are congruent, so any of the parts I want to choose can be congruent to each other. I could say that HG is congruent to IJ. I could say that IG is congruent to HI. I could even say that angle I is congruent to angle H. Any of the parts we haven't used yet. But they asked me to pick IG and HJ. So that's what I'm going to pick. IG is congruent to HJ because the corresponding parts of congruent triangles are congruent. Again, if you forget how to list those letters, it's the definition of congruent triangles or some explanation that you understand what the concept behind the corresponding parts. Okay, so important thing to notice here, parallel lines. You're always, 99% of the time, you're looking for the alternate interior angles. Every once in a while it's corresponding, but most of the time it's alternate interior angles. The given gives you parallel lines for a reason, and you're supposed to pick the angles out of that. All right. Let's see if there's another one we could do. I'm going to do number 6. And then I'll go back to the one from the previous day's notes because I promised we would. Number 6 says O is the midpoint of NP. O midpoint NP. And it also says that angle N is congruent to angle P. So I'm going to label those things in my picture. Now remember, midpoint, when they give you a vocabulary word in the given, you're probably going to use this definition in one of your steps. So I know the definition of midpoint is that there are congruent segments. So if O is the midpoint of NP, my congruent segments are NO and OP. That's going to be definition of midpoint. So you always, if they use the word bisect, you're going to use definition of bisector. So you always use the vocabulary word as the definition in one of your steps. All right, I call this one the bow tie picture. And remember, we had our vertical angles here. Now, you are welcome to do this if you want to. You can name this angle with all 3 letters because you can't just say angle O and angle O. Or if you want to be sneaky, I'm going to name that angle 1 and angle 2 because I don't want to write all the letters. And you can do that. If you label your picture, you can use those labels in your proof. And that was because vertical angles are congruent. Remember, never ever the definition of vertical angles. That's not going to be right. So I think I have enough information. I've got 2 angles and a side. I can prove the triangles are congruent by angle, side, angle. Here goes. Just be sure to match up your letters. So the first triangle you name however you want to. I'll name it SON. And now I just have to make the second one match the first one. So if I said SON, I'm going to say ROP. And my reason was angle, side, angle. Alrighty. Now I'm supposed to prove that O is the midpoint of SR. So I've got to figure out how to do that. Well, we're kind of going in reverse. We started with a midpoint, and now we're going to prove something's a midpoint. If O, I'm going to skip, I'm going to say number 6 right here. It's going to say O is the midpoint of SR. What needs to happen in order for O to be a midpoint? I've got to have 2 congruent segments. Which 2 segments have to be congruent in order for O to be the midpoint? Well, that would be this one and this one. So I'm going to say that SO is congruent to OR. Because my triangles were congruent, all of the corresponding parts are congruent. And if segment SO is congruent to segment OR, that makes O the midpoint because that's the definition of midpoint. So we did use definition of midpoint twice, and we kind of used it in 2 different ways. First we said O was the midpoint, so we have congruent segments. And then here at the end, we said we have congruent segments. That made O the midpoint. So you kind of have to think your way through them. Sometimes you start at the end and go, what do I need to do to get here? Kind of like a maze. When you start working out a maze, you start at the top and work your way, and then you go to the end and you meet back. Sometimes we do that in a proof. So that's a really good example. All right, I'm going to walk you back to the one I did not finish in the last lesson. Remember this one? I promised to come back to it, so here I am. It says we started with the congruent segment, so we had an isosceles triangle. So we said that these orange triangles on the outside ended up congruent because of SAS. All right, now watch what I'm going to do. I'm going to use corresponding parts of these 2 orange triangles, and that's going to help me out. I'm going to use EB and EC. when you use your CPCTC, you can prove any corresponding parts you want to. You can pick any angles, any sides that haven't already been used. I picked these for a reason. Take a look. If EB is congruent to EC, right here, then what kind of triangle is EBC? So ignore the outsides now, just look at the one in the middle. Well, if it's got two congruent legs, it's isosceles. So if two sides are congruent, what do we know about angle 2 and angle 1? If two sides of a triangle are congruent, then the angles across from them are congruent. That's the isosceles triangle theorem. So that was some creative thinking on that one. Sometimes when you're doing a proof, like a lawyer in the courtroom, you've got to be a little bit creative to use what you know to get your end result. So that is the CPCTC, the corresponding parts of congruent triangles. It's just the definition of congruent triangles. You have to have congruent triangles first, then you can prove any of their corresponding parts are also congruent.